In question 5.4, we have an identity, a rather nasty one if I do say so myself. Right, so I'm going to start with the left-hand side because it looks more complicated. So let's get the left-hand side down quickly. And now I'm recognizing quite a few things with the left-hand side. I see a double angle there, a double angle over there, and I see a tan here. So predominantly what you want to do is you want to sort out the denominator first. I'm not going to touch this double angle until I see how this unfolds. So I'm going to change sine 2 theta into the respective double angle. So let's grab that formula quickly. And just remember, this is on your formula sheet, so you don't have to know them off by heart. And then there's only one double angle formula for sine of 2 theta. It's this bottom one, so I'm going to get rid of the others for now. And let's go ahead and change the sine 2 theta into 2 sine theta cos theta. And then this tan theta, it's a trig identity lurking about. So let me just quickly remind you of those grade 11 ones you need to know off by heart. And remember, I can change tan theta to sine theta over cos theta. I'm going to ignore these other three for now because we're not using them. And now after that replacement, we are getting somewhere. So now I want to get an LCD before I decide what to change this to. Because remember, I have three options in my formula sheet to change this. So I don't really know which one to change it to until I get the LCD, simplify stuff, and then I can make a much more informed decision. So the LCD will be this thing over here. And this denominator is missing two factors. It's missing this 2 and it's missing a sine theta. So I've got to multiply the top and the bottom by 2 sine theta to achieve that LCD. Okay, so we're just going to multiply the top and bottom by 2 sine theta as discussed. This fraction will stay exactly the same. Nothing's going to happen to that fraction. And then sine theta times 2 sine theta. 2 times 1 is just 2. And sine theta times sine theta is sine squared theta. And then at the bottom, cos theta times 2 sine theta will give us this. 2 sine theta cos theta, which was part of our plan the entire time. And now we've got both fractions over the LCD. So we kind of morph them into one fraction like this. And you want to get kind of comfortable enough to do that all in one step. So yeah, basically there's our LCD sorted out. And now I can finally make up my mind as to what I'm going to change this cos 2 theta to. So let's grab our double angles once again and make an informed decision of what we should change it to. Okay, so these are the three options I have available to change this cos 2 theta. And my decision is going to be based around this, what's on the right hand side. So at the end of the day, I just want sine theta and cos theta at the bottom. So I need to get rid of this 2. And to do that, I need a 2 on top to cancel. And I'm also noticing this. This looks an awful lot similar to that. And if I make the selection of this double angle, and this one's a minus and this one is a plus, they will cancel each other out. And I'll get 1 plus 1, which will give me 2, cancel with this 2, and then I've got the right hand side. So I'm going to choose the middle one. And after I replace cos 2 theta with the necessary double angle identity, we're going to watch the magic happen. Now minus 2 sine squared theta plus 2 sine squared theta, they cancel. What a dream. And 1 plus 1 is 2, so at the top we just left with 2. And now, because we have one term over one term, we can cancel the 2's with one another. And then we're left with this, the right hand side. And then there's one last thing I need to do. I just need to say equals RHS, because we need to prove the left hand side equals the right hand side. So I do have to write that. Just like that. And let's have a look where our 5 marks come from with this nasty little identity. The first mark comes from changing sine 2 theta to 2 sine theta cos theta using your double angle identity over there. Second mark comes from changing tan to sine over cos. Remember to tan your socks. Tan equals sine over cos. That's how I remember it. Third mark comes from our LCD. The fourth mark comes from the double angle identity we apply to this cos 2 theta. And the last mark comes from simplifying this, cancelling your terms to get this expression over there. And that wraps up our identity.